Pardon?
Yeah, I do.
Do? So once a question I always forget to put on the questionnaire is if you have a pet. Help for a question. Okay. So if we read the question, right, this is an easier two-dimensional one. Because we only have one vector on an angle. That's what makes it easier, not two like the next one. Or three like the one after that. So the beauty of this one over using the cosine law and sine law is that if you have 5 vectors, you can just add the components together for all 5 vectors. It makes it easy, as opposed to using cosine law and sine law multiple times. So step 1 was start with a diagram. So we're not starting with the table of values this time. So our diagram, we have to make sure that we leave enough room on our page to make this work. We're going north, and then we're going east with a little bit more north. So make sure you don't start very high. Okay, so for this diagram here, north and east are positive. If you have different colors, sometimes people like doing it in different colors too. I know students like that sometimes. Right, D1 is just going north, so it doesn't have any component. And D2 is obviously on an angle, right? And that has components. So I've labeled them up there. I have not put the total displacement up there because it will make my diagram really messy. But it's the angle from the start to the finish. You can include it if you want, but well, I'll put it in red. Don't feel like you have to do it. But it goes from the bottom down here through all of this. There. Alright, that's what we're trying to find, the resultant displacement. From the start to the finish. So that was step 1, right? Draw the diagram. Any questions with setting that up? Okay, so step 2 was the table of values, right? So we have delta 1. So if I were in your shoes, my suggestion is to take your page underneath your picture and split it into 2. So on half your page, on like say the left side, let's call that the X direction. So we'll list everything in the X direction on one side of the page. And the Y direction will be on the other side of the page. Do you have to do this way? No. You can do whatever makes sense to you because you have to organize your own thoughts. I just like the separation. I know the first vector is only going north, so it doesn't have anything going east. So that would seem silly, but I'm going to include it there anyways, just so I don't forget about it or have second guesses. The second one is a little bit challenging. And I know it's going to be this number. Any idea how I came up with that? It comes back to my picture, right? It all comes back to the picture all the time. Ashley?
Well, like, also in the question, it said like 15 meters north, and then it said she took a turn, and then
Yeah.
she would have went up if we're saying like do you want to go north, and then it said she took a turn, so then she.
Yeah. Why did I choose cosine here instead of sine or tan? That wasn't a random chance that I chose that. Patty?
Well, cos is adjacent over hypotenuse, and the hypotenuse is due
Yeah, good. So when you look at this, you don't have to write this, but I'm only going to do it this one time because you're all new to this, right? So we know that cos 53 is equal to adjacent, which is delta d2x, over delta d2, right? The hypotenuse, right? Adjacent over hypotenuse. Right, so if we rearrange that to get delta d2x, right? So we have delta d2x. I bring that over here, so that's delta d2 cosine 53. And then I just put 10 in there, just put it over there. Okay, you have to use your triangles in your pictures, right? Making sure your angle's in the right spot, because it's not always cosine there. Sometimes it's sine on the x side, so it depends on where your angle is. Under?
So are you going to do this every time you have a angle?
Yep. You are.
So suppose the tangent would be opposite over adjacent.
Yeah.
It'd be,
But we don't have it.
in this case, what would be opposite over adjacent?
Be y over x.
Y over x.
Yeah. All right, so for the y1, right? So for the y table, right, we have same thing, delta 1y, which is our 15 meters north. And we have delta 2y, which is 10 meters sine of 53 degrees north. So again, all the directions match up to my compass system. Right? I said north and east are positive, so in my tables I have north and east. Students who might get this question wrong don't put directions where they should, and they might miss a negative sign. So take your time, make every little point that you can. So that was step 2 in our list, right? Step 3 was to solve the questions in each dimension. Right, so this one, we're just doing some adding. We have delta dr is equal to d1x plus d2x. I think that's 6 meters. Okay. And then we repeat for the y. So same steps. Alright, so we're just taking the numbers in our table of values there, just adding them together. Right? But if we had something like, say, in the north, in the vertical part there, if we had something that said south, right? Remember, there's a negative sign that jumps in there. Alright, so that's step 3. Alright. And then, step 4, we have to use the Pythagorean theorem to put those pieces together and the tangent ratio to find the overall direction. So what I like to do is, for step 4 here, is I like to redraw the resultant vector, like what I'm trying to find. So if I draw it like this, delta d ry, delta d rx, r. So I'm going to redraw a triangle, right, which is my red line over there. So I'm going to label my angle in there, so when I do the direction in a second, I know where I'm measuring my angle from. It does not matter if I do this triangle or do this triangle with a different angle in there, because they both describe the same vector in the end. Your angle will be, if this is 30, then that one would be 60, right? Because it still works the same way. Okay, so we have our magnitude of R. So just like we described it before, right? We use the Pythagorean theorem. Sometimes it looks harder than it is because it's a lot of letters, right? But we have all our information there. So 6 meters plus 23 meters. What's the actual answer? I don't feel like it's 23.
24.
24?
23.77.
All right. And then we find the angle there, which is theta, right? So that is opposite over adjacent, so the 23 divided by 6 should give you around 75. You can tell me if I'm wrong. All right, so then if you go through it, and then your therefore statement at the end ties everything together, right? So Ashley's overall displacement is 23.77 meters east, 75 degrees north. Or it could be north 15 degrees east if you solved it in a different way. That is a huge question and has lots of steps. So what we did last week pales in comparison because that was hard figuring out the variables, but the equations for most questions were just plug and chug. Here, as you're seeing, maybe it took a whole page on your piece of paper. It does take lots of time and thinking, so take your time. If you had, just a second, Andre, if you had 3 vectors or 4 instead of just the 2 in the question, it doesn't take much more because all you're doing is just adding one more line up here, adding one more variable in here, and then the process is still the same. Right? If you add 10 vectors, you just have 10 listed up here, adding all 10 together and still getting an answer, still doing these steps over here. Right? So the process works the same for 2 or 100. Is it tedious? Yes. But it works every time. So you just have to take your time, go through it slowly. Right? Students who get questions wrong, rush, and they switch the sine and cosine in the wrong spot. Right? So you might lose a mark on a test if you do that, as long as everything else is right. So take your time. Don't lose negative signs. Make sure your trig stuff's in the right spot. Andre, what was your question?
Yeah, can you just like go through where you're finding the red line? I know you find it at the bottom of X and Y. Is that am I right?
Say that again. Where am I finding the red line?
Yeah.
So
the
the
displacement.
resultant displacement varies from the start to the end.
Yeah.
So that would be Ashley's real displacement, right? That's the same as that line over there in that triangle.
Which one?
The hypotenuse.
Hypotenuse.
Yeah. So that line here is this line here.
And then where's DRY?
So if I go back to this one, is where it gets messy. So GRY, or like this would be delta DRX here, right? And this would be delta DRY here. And this is our angle here. I just slid that red triangle over there.
Over where there?
Yeah.
And then for this Y, why are you finding DRY for DRY? Isn't it displacement?
Right? We have to find this side of the triangle, right?
Oh, okay.
Right? Which is this line here plus this line here.
Oh, okay. So for X, you're finding DRX.
Which is just this, and there's only one of those.
So he uses his little.
All right.
Does that make sense?
Yeah, that makes sense. And then over there, you just connect it all.
I just connected them all together, right? This blue line here,
So he
I'm
has.
gonna switch the elevator back so you can see what we're talking about. All right, so that blue, these two components, right, gives you that whole line, which is what we did here. Or, sorry, over there.
Another reason he was signed.
Where's D1Y?
He's essentially.
D1Y?
The same triangle, but the inverse.
Just the line that goes straight up, right?
He has,
D2Y.
in which he's not trying to find the adjacent.
Because I could redraw that picture, right? I could have, this could be my D1Y, and that's still D2. But I could take this triangle and make it easier and break it down this way. And that would be 37 degrees.
Like it's just getting the numbers.
And then
Like,
you have
it's a really
X.
simple concept because it's just
I get
finding
the
the
same
total X distance and finding the total Y distance, and then you're using it.
Jaden?
I'm just confused on how you knew it was like a closer side. I don't know if you explained this already, but.
It's okay. So your cosine is here, right? So that's your cosine of your angle is off or adjacent over hypotenuse, right? The y direction is the opposite side over here of my triangle. So that's y is going to be sine of 53 degrees is equal to delta d 2y over 10 meters. So that's where these guys come from here.
Okay, thank you.
Does that make sense?
In the fourth step where you do 15 m plus 10 sine 53,
Yeah.
why do you use 53? I'm a little confused.
Want to use 53?
Yeah, because
That's the angle, isn't it?
So in the first question.
But what I'm confused about is, aren't you? Hold on. You're essentially your first triangle, or your first initial triangle that you're using to find. Oh god, there's too many variables.
Here?
Yeah, so you find that delta d2x.
I know that. I know this, yeah.
Yeah, so you find that, right?
Yep.
And then next, you're trying to find,
This.
yes.
Yep.
Oh, I see.
I don't want to use can, which is your other option, because if you screwed up somewhere here, then that's going to make that wrong too.
Right.
You should. The rule is you always use the numbers given to you in the problem.
Okay. Because I was thinking you had to make an entirely new triangle essentially from mine, or like
No.
like the square equivalent.
Yeah. Does
But
that make sense?
I like the new triangle.
Maddie?
Just a little confused on why you put D1 X at 0.
Because D1 is just vertical, right? North. So it doesn't go east-west.
Oh, so, but if it did go over.
If it did, like
over,
here.
Or you have to do another triangle?
Right here, right? Look at this, right? We have an angle and an angle.
So you would just do what you did for the top. Like that?
Yeah, just twice. Everything that you have on an angle, you have to break it down into its components. Right? If there's 3 vectors, you gotta do it 3 times.
My communications.
Oh yeah, I'm gonna have no communication.
So I would suggest
So it's total.
that we have 10 minutes left, that you try to get this question done in 10 minutes. Okay? You do it now. Don't stare up here and try to figure it out. Try to figure out while you're working through this. Because I can help you if you get stuck. And then you make your homework go a little bit more smoothly. So don't leave the classroom until you get this question right. Okay? Let's make sure we get it right. You have 10 minutes. Good luck.
Are the